Good morning, friend. We have already completed 3 lectures for trigonometry, that is 8.1, 8.2 and 8.3. This is the now last lecture reference with 8.4. So before we start exercise 8.4, we have to understand the identities. So that is called trigonometric identities. When we start trigonometry identities, we have to first draw one right angle triangle. So let we take triangle ABC in which measure angle B is equal to 90 degree, and we have to draw one right angle triangle, and here it is A. Now if we apply the Pythagoras, then AB square plus BC square plus AC square we get. Now if I divide all this by AC square, then some relation I get. AB upon AC, BC upon AC. So BC upon AC and AC upon AC, I will get one answer. Here BC upon AC, so if you will take Soch and Kh, Soch means sines. Sine is equal to opposite, that is BC upon AC. So I can write it here sine square A. I can write it here cos square A. Why? Because Kh cos theta adjacent, that is AB upon AC. So that way we can get three identities. So let we see. First identity, AB square plus BC square is equal to AC square. Dividing each term by AC square, we can get AB square plus BC square is equal to AC square divided by AC square. AB upon AC whole to square plus BC upon AC whole to square is equal to AC upon AC whole to square. Now already we know that Soch Kh, so we are using this at here. AB upon AC, adjacent upon hypotenuse, adjacent that is AB, hypotenuse AC. So we can write cos square A. BC upon AC, we can write sin square A, and here it is 1. So first identity, that is actually like that, sin square theta plus cos square theta is equal to 1. That is our first identity. How we can make this identity? By applying Pythagoras, and with divide by AC square, we can get one identity, that is sin square theta plus cos square theta is equal to 1. Same thing, if I will divide this equation again by BC, we can get some another identities. If I divide it by again with AB, then we can get another identity. Now if we divide it by AB square, that given equation Pythagoras, that is AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. Now if we divide it by AB square, so AB square upon AB square plus BC square upon AB square is equal to AC square upon AB square. So if I divide it, if I divide it by AB square, we can get, here it is 1, here BC upon AB, so it is a inverse of tan TOA. So TOA means tan theta is equal to opposite upon adjacent. So tan A is equal to opposite, that is BC upon AB. So tan square is equal to sec square. So second identity, 1 plus tan square A is equal to sec square A. Now if this again we divided by some, we divide already by AC square. एक से डिवाइड कर दिया, दूसरी बार AB स्क्वायर से डिवाइड कर दिया। नाउ किससे कर सकते हैं, तो के BC स्क्वायर से डिवाइड करेंगे। नाउ डिवाइडेड बाय BC स्क्वायर, we can get some another result. So if I divide it by BC square, again AB upon BC whole to square plus BC upon BC whole to square is equal to AC upon AC whole to square. So overall we can get three result, that is sine square theta plus cos square theta is equal to 1 plus tan square theta is equal to sec square theta, 1 plus cot square theta is equal to cos x square theta. Three result we have got. So from these three result we can get some more result. If I will shift this cos square को लेफ्ट हैंड साइड से राइट साइड ले जाएंगे, then sin square theta is equal to, I get answer 1 minus cos square theta. We can use this identity, or cos square theta is equal to 1 minus sin square theta. Same thing, tan square theta plus 1 is equal to sec square theta. So we can get more two identities. So these most important three identities. Afterward we convert into more two identities. From first, from second equation again we have get two more identity. Again we can get two more identity. Cot square theta plus 1 is equal to cos x square theta. So we can use cos x square theta minus cot square theta equal to 1. Cos x square theta minus 1 is equal to cot square theta. So 9 overall identities are there. First, second, third, fourth, fifth, sixth, 7, 8 and 9. Total 9 identities, and all are important for us. So anyhow you have to write at least 4 or 5 times in your fair book. Then we can use this identity for exercise 8.4. Now we see some example related exercise 8.4. Express the ratios cos A, tan A, sec A in term of sin A. Means our answer must be in sin. So first of all, that is identity. First identity, cos square A plus sin square A is equal to 1. So cos square A is equal to 1 minus sin square. Therefore cos A is equal to plus minus under root 1 minus sin square A. So we can use plus identity, not a minus, because answer is positive of answer is 1. So we can get first cos A, that is under root 1 minus sin square A. So that we get. Now tan A means sin A upon cos A. Sin A upon cos A means we have get value 1 minus sin square A. So sin A upon under root 1 minus sin square A. Now if I want to get value of sec A is equal to 1 upon cos A is equal to 1 upon cos means what? Under root 1 minus sin square A. So that way we have get all answer in sin form. That is cos A under root 1 minus sin square A, tan A sin A upon under root 1 minus sin square, sec A, that is 1 upon under root 1 minus sin square. So that type of questions is in your exercise 8.5. Another, by using identity, what we have prove that sec A 1 minus sin A bracket sec A plus tan A. So first of always remember that everything we have to convert into sin and cos. ट्रिग्नोमेट्री का एक बेसिक रूल है, कि all functions को convert करो sin और cos में. So here sec k is there. So we write 1 upon cos a. Afterward 1 minus sin a as it is. Again sec a 1 upon cos a plus tan a means sin a upon cos a. Now if you will see that denominator is same. So cos a is here one time. So 1 plus इसका आंसर क्या रहेगा 1 plus sin a upon cos a. So 1 plus sin a upon cos a और ये था एक बार नीचे cos a. So this cos a and cos a cos x square 1 minus sin 1 plus sin. Now difference of sign, difference of square x plus y, x minus y. We can get answer x square minus y square. So 1 minus sin square a upon cos square a. But we know the identity 1 minus sin square a means cos square a. So cos square upon cos square, that we get answer 1. So that type of sums in your exercise 8.4. But according to the board rules, only 1 to 4 question you have to do anyhow properly. Now we go for exercise. Okay, one more example that we have to see again. Cot A upon cos A divided by cot A plus cos A is equal to cos A k minus 1 upon cos A k plus 1. So we have to concentrate from here. Cot A minus cos A upon cot A plus cos A. So instead of cot, what we have decided that everything you should convert into sin cos. So cot A means cos A upon sin A minus cos A. Again cos A upon sin A plus cos A. So here if you will see cos is common. Again here cos is common. So we will take outside cos A. In bracket we have to write 1 upon sin A minus 1. Upon this cos A cancel. 1 upon sin A plus 1. But we know that 1 upon sin means what? Cosec. 1 upon sin means cosec. So cosec minus A upon cosec plus A. That type of proof may be asked according to the board. 2 marks question. Now let me see some more exercise, that is exercise 8.4. Okay. So express the trigonometric ratio sin A, sec A and tan A in term of cot A. So anyhow I want to get answer sin A in form of cot A. Sec A again in form of cot A. And tan A, that already we know tan is equal to 1 upon cot A. So it we get हम लोग को tan A is equal to 1 upon cot A, we can get answer. Sin A we have to convert into cot A. So instead of sin I have to write like that, sin square A we can write, because under root 2 बाहर निकलेंगे तो sin A. Now sin A means what? 1 upon cosec square A, because inverse of sin is 1 upon cos. Inverse of sin is 1 upon cosec. Now cosec means what? So we know that 1 plus cosec square theta is equal to cot square theta. So cosec square theta is equal to cot square theta minus 1. So I write it here, cot square theta minus 1. So under root if you will remove this, then 1 upon answer is cot square theta minus 1. So we can get answer sin A in form of 1 upon under root cot square A minus 1. Same thing we want to get sec. So that is a first we clear it. Let me see that whatever we are explaining is correct or not. So sin A under root sin square, same thing under root 1 plus cos x square A. Cos x means 1 plus cot square. 1 plus cot square A is equal to cos x square A. So I am using wrong identity in earlier sum. So 1 plus cot square is equal to cos x. Again I write all the identities. We have to remember this identity anyhow. Oh, sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta. 1 plus cot square theta is equal to cos x square theta. Now let me see that sec they have to. So cos A, that is under root cos square A. Instead of cos A we can write 1 minus sin square A. Instead of sin, we know that sin theta is equal to 1 upon cosec theta. So under root 1 minus sin square A, under root 1 minus 1 upon cosec square A. Instead of sin I have to write cosec. Now cosec already I have identity, that is cosec is equal to 1 plus cot square. So 1 minus 1 upon 1 plus cot square. Now if I will take LCM of it, 1 minus 1 plus 1 upon cot square A. Now it should be at here. So 1 plus cot square A minus 1. It should be cut. So cot square A, it should be cut. Cot square A upon 1 plus cot square A. But under root is there. So cot square should be removed and convert into cot A. That is cot A under root 1 plus cot square A. Now if I want to find out tan A. So already we know that tan A is equal to 1 upon cot. Tan A is equal to 1 upon cot A. Same, write all the other trigonometric ratio in term of sec A. So I want to convert everything into sec. Again same thing, we can do it or not. So sin A, I am writing at here sin A, that is under root sin square A. Now I am write 1 minus cos square A. Why I am writing 1 minus cos square A? Because it is identity. Now cos is the inverse of sec A. So this sec will be at here. So sec square A minus 1 upon sec square A. If it will be removed under root, then sec square A minus 1 upon sec A. Let we see that they are doing like that or not. Sin, that is under root sin square A, under root 1 minus cos square A, cos A inverse of it, that is 1 minus 1 upon sec square A. If I will take LCM of it, then we can get sin A is equal to under root sec square A minus 1 upon sec A. Now what? Cos, same thing we can do it. So cos A is equal to 1 upon sec. We can get answer in sec, so it is easy. Now if I want to find out tan A, then tan A is equal to sin theta upon cos theta. Sin theta already we have get. And value of cos, that is 1 upon sec A. So this sec A cut. So we can get answer tan A is equal to under root. So sec A is equal to under root n square A. Same thing, we can get same answer under root sec square A minus 1. Because it is a identity. Identity is what? 1 plus tan square A is equal to sec square A. Now we want to get answer in sec a. So tan square a is equal to sec square a minus 1. Therefore tan a is equal to under root sec square a minus 1. So that way we can get answer. So we can get now all functions, that is sine we have get, cos we have get, tan we have get, now cosec. So cosec is equal to under root cosec square a, that is 1 plus cot square a, that is 1 plus 1 upon tan square a. Tan we know the value of, that is 1 plus 1 upon, or directly what you have to do, sine a is equal to 1 upon cosec a. Therefore cosec a is equal to 1 upon sine. Now we can get value of, already we have a value of sine, that is under root sec square a minus 1 upon sec a. So denominator should be denominator should be numerator. So answer is sec a under root sec square a minus 1. So it is also correct way. Now cot a, that is under root cot square, that is under root 1 upon tan square, that is under root 1 upon sec square a minus a, that is under root 1. But we can write also cot a is equal to 1 upon tan. So already tan value we know, that is under root sec square a minus 1. So that way we can get all value easily. So इस प्रकार के सम एग्जाम में आ सकते हैं. You have to write everything in your pair book, that is exercise 8.1 question 1 and 2. There are, now we go for proof. This question is also in exam. So what we have to, already yesterday we have discussed that in last lecture, that numerator denominator cancellation is always answer 1. Always remember. Now that is sine square 63 I have to write as it is, and here cos square 90 minus 27. Same thing, cos square 17 as it is, here sin square 90 minus 73. Now if you will see that we can convert sin square 63 as it is, here cos square 63. So theta is 1, sin square theta plus cos square theta. Theta is always 1. So we can get here answer 1. Again cos square 17 as it is, here sin square 17. Again answer is 1, that is 1. That way we can get answer of 1. Second, sin square 65 cos 65. So sin 25 degree cos 65 degree plus cos 25 degree sin 65 degree. Anyhow I have to convert 1. So sin 25 degree, here we can write sin 90 minus 65. Again cos 25. Again here cos 90 minus 65. So here we can get sin 2 times. So sin square 25 plus cos square 25. So theta is same. So answer is 1. So that way we can do it. Let me see that they are explaining correct or not. So sin square 63 plus sin square 27. So again instead of sin square I have to write cos square 90 minus 27. So these are all the complementary identities. So we can write sin theta is equal to 90 minus theta, or cos theta is equal to 90 minus theta. So we can get answer 1. Next, in sine 25 cos 65. So instead of sine, we can write cos 90 minus 65. Same thing at here, but anyhow we have to make theta equal. So cos square 65 plus sine square 65. Any one functions we have to convert out of two. That is sine and cos is there. Then I have to convert. If I convert sine at here, then you have to convert cos at here. So you will get same, that is cos square 65 plus sine square 65. You will get answer 1. Now proof, that is important for us. Prove that the following identity where the angle involved are acute angle for which express are defined. So this type of proof may be asked in exam. So first of all, what we have discussed, everything should convert into sin cos. पहले क्या बताया गया है कि जो भी ट्रिग्नोमेट्रिक फंक्शंस है उसको sin cos में कन्वर्ट करेंगे. So 1 upon, यहाँ पे करते हैं 1 upon sin theta minus cos theta upon sin theta. So we can get 1 minus cos theta upon sin theta, and in bracket over here it is a square. So I have to write 2 times 1 minus cos theta, 1 minus cos theta, and sin square theta. But we know that sin square theta is equal to 1 minus cos square theta. So 1 minus cos theta, 1 minus cos theta 2 times, and in denominator we have write 1 minus cos square theta. So 1 minus cos square theta means one time plus and another time minus, एक बार plus और एक बार minus. So 1 minus cos theta, 1 minus cos theta, and in denominator 1 plus cos theta and 1 minus cos theta. So that should be cut. So 1 minus cos theta upon 1 minus cos theta. Let me see that we are doing this correct way or not. So cosec minus cot whole to square, that is 1 upon sin a minus cos upon sin a whole to square. Here it is a bracket. 1 minus cos theta whole to square, denominator is same, that is sin. Now open the bracket, that is 1 minus cos theta whole to square divided by sin square. So 1 minus cos theta whole to square and sin square, we can write 1 minus cos square. That is 1 minus cos, 1 plus cos, that we will cancel. So 1 minus cos upon 1 plus cos. Now we go for second, we can take LCM of it. That is, if you will go simplify it here, then cos square a plus 1 plus sin a, and denominator cos a in bracket 1 plus sin a. Now if you will see, there is a whole to square is there. So x plus y identity, that is x square plus 2xy plus y square. So if we will open it, then cos square a plus 1 plus 2 sin a plus sin square a upon cos a 1 plus sin a. Now cos square a and sin square a identity is 1, and already 1 is here. So 1 plus 1, 2 plus 2 sin a. If I will make outside 2, then 1 plus sin a. So if 1 plus sin a is there, so we can easily cut. So 2 upon only cos a is remaining. So we can get 2 sec a. Now let me check that we are correct or not. So left hand side first we have to take. cos A upon 1 plus sin A plus 1 plus sin A upon cos A. Cross multiplication or LCM, that is we can take LCM at here. So cos square A 1 plus 1 sin A whole to square upon 1 plus sin A bracket over cos A. So cos square A plus 1 plus sin square A plus 2 sin A upon 1 plus sin A cos A. So again identity, already we say that here we are using 1 cos square A and sin square A. Answer is 1. So 1 plus 2 sin A. So 2 will take common outside. So 1 plus sin A upon 1 plus sin A cut. So 2 upon cos A, that is 2 sec A, that is RHS. We have to prove anyhow left hand side into left hand side is equal to right hand side by using three identities and relation of sine with cosec, cos with sec, tan with cot. Next sum. 1 plus sine, 1 minus sine. So when such type of sums are there, in 9th standard we are rationalize the denominator. Same thing we have to do at here, rationalize the denominator. So if minus sign is there, then I have to write plus sign. So in numerator, sin 1 plus sin A whole to square, and in denominator 1 minus sin square A. When under root is there, then this square will be removed. So we can get 1 plus sin A. Here 1 minus sin square means cos square A. Again under root remove that 1 plus sin A upon cos A. Now divide each term, that is 1 upon cos A plus sin A upon cos A. That way we can get answer. Let me see that we are correct or not. So under root 1 plus sin A upon 1 minus sin A. We have to rationalize this. That is 1 plus sin A. Again rationalize means to remove the denominator. So now in numerator we can get 1 plus sin A whole to square. 1 minus sin A, 1 plus sin A. That is, here they write directly, but we have to explain that 1 minus sin square A theta is equal to cos square theta. So that is identity we use. So under root 1 plus sin A whole to square upon cos square A. So when we remove this under root, it should be removed. So 1 plus sin A upon cos A, and divided each term with cos A, we can get sec A plus tan A, that is equal to RHS. So that is the important proof related to trigonometry. Now we go for 7th sum. Sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. Now if you will see here, sin is common. So 1 minus 2 sin square theta we can write. Same thing, cos theta we can take common. Then 2 cos square theta minus 1. Now sin theta, cos theta, that is tan theta. So anyhow we have to remove this bracket. So how we can remove? We have to put as it is numerator. In denominator we can change. So 2 cos square theta. Instead of 1 we can write sin square theta plus cos square theta. Or we can write 2 in bracket 1 minus sin square theta minus 1. So 2 minus 2 sin square theta minus 1. So 2 minus 1, that is 1 minus 2 sin square theta. So we can get instead of this 1 minus 2 sin square theta. So that we can easily cut. Let me see that we are correct or not. So they take outside sin theta in bracket 1 minus 2 sin square theta divided by cos theta, bracket 2 cos square theta minus 1. Simplify, we can get tan 1 minus 2 sin square theta. As it is, instead of cos square theta, we write 1 minus sine square theta. If you open this bracket, then 2 minus 2 cos square theta minus 1. So plus 2 minus 1, that is 1. So that should be cancelled. So sine theta upon cos theta, we can get tan theta. One more sum, let me see. All sums, whatever I am explaining at here, these are all board sum. So here square identity is there. So we can open this sine square a plus 2 sin a cos a plus cos x square a. Cos a means cos square a plus 2 cos a sec a plus x square a. Now if we add this, then sin square theta plus cos square theta. Here we can get answer 1 because they are sin theta is equal to cos x theta. 1 upon sin theta is equal to 1 upon cos x theta. Therefore sin theta into cos x theta, answer is 1. So 2, again here same thing, we can get 2. So 2 plus 2, that is 4, and here it is 1, that is already we can get 5. Now cosec, instead of cosec I can write 1 plus cot square a, and instead of sec square a I can write 1 plus tan square a. So that 5, 6 and 7. So that we get answer 7. Let me check that by board rules. Sin a plus cosec a whole to square. So sin square a plus cos square a plus 2 sin a cosec plus cos square a plus sec square a plus 2 cosec sec a. Now these sin square theta plus cos square theta, we can get answer 1. Cos x square as it is, sec square as it is here, we can get answer 1. Again here we can get answer 1. That is already described here. So 2 plus 2. This is 2 plus 2 and here it is 1. So we can get easily 5. Now instead of cosec, 1 plus cot square a. Instead of sec, again 1 plus tan square a. And if we total it, you will get answer 7 plus tan square a plus cot square a. So overall we have completed this exercise. You must go through the lecture and you have to write the comments, or so if you have some doubt you can send me in WhatsApp so we can solve it.